Hi, this is the last part of a video series to solve questions that came into an ACT mock test. So this question, you're given a function on the graph and it's a linear function, and you're asked to find the expression that represents this line. So we know that any linear function can be expressed as if y equals mx plus b, where m represents the slope of the line, which is equal to the rise over the run of between 2 points in the space on the line, and b is called the y-intercept. So in this question, it's clear that the y-intercept is located here. So the y-intercept is the value of the y-coordinates. So the y-intercept is just -5. So if you go to those selections, we have A has a -5, this has a -5, this one has a -5, so we can exclude D in this case. Another thing you can notice that this line is oriented in this direction, so we know that if you have a line oriented in this direction, then this has a slope which is positive, greater than 0. And if you have a line that looks like this, then this has a slope which is negative. So this line has a slope that is negative, which means that this is positive, so we can exclude also this one from our options. So we have two options, either A or B. So how do I find the slope? Is the slope -2 or -3? So I have 2 points here. So I have x1, I have x, I have y1, and I have x2, and I have y2. So all what you need to do is to calculate the slope. So y2 is -5 minus y1, which is -1, divided by 0 minus -2. So that will give me -6 divided by -2 is +2. So the answer is -3. In this case, this is the correct answer. Now let's move to the second question. It says, what is the value of c squared minus d squared if c plus d equal to 7 and c minus d equal to -2? This is a straightforward question, and you need to remember this property is the square difference. The square difference is c squared minus d squared is always can be factored as c minus d times c plus d. So c plus d equal to 7. So that's 7 times c minus d equal to -2. And the answer is -14. So you need to remember this property in order to solve this question. The third question says that you have a certain high school with a ratio of left-handed. So let's call this left-handed by LH and right-handed basketball players. So the ratio of left-handed basketball players to right-handed basketball players is 1 to 4. So this means that, okay, if you have a total of 20 players on the team, how many players are right-handed? So it's clear that for every one left-handed player, you have 4 right-handed players. So in this case, one way to do this question is to find the fraction of the people or of the players that are left-handed, and the fraction, so this is the whole 20 team players. What is the fraction of the left-handed players? What's the fraction of the right-handed players? It's a very interesting trick to know the fraction. So the fraction of the left-handed players is just LH divided by LH plus RH, and the fraction of the right-handed player is just RH over LH plus RH. So here we have it's 1 over 1 plus 4, which is 1/5, and here is 4 over 1 plus 4, which is 4 over 5. So the number of players that are right-handed is simply, so 4/5 multiplied by the total number 20, so that will give me 16. So 5 cancels out with 20, that will be 4. 4 times 4 is 16 players, so this is 16, and this is just 4 players, and the answer is D. The next question says that there are twice as many red pins as there are blue pins in a box. So the best thing to approach these word problems is, let's draw a box, and we have red pins R, and we have blue pins B. So we have twice as many red pins as the blue, so R is equal to twice B. If a pin is randomly selected, what is the probability that it is blue? So the probability that we pick a blue pin, according to the probability theorem, this is equal to the number of blue pin in the box divided by the total number in the box of pins, blue and red. So this is equal to the number of pins of blue divided by the number of pins that are blue and red, is equal to simply NB plus NR. And then from this formula, the number of red pins equal to 2 times the number of blue pins. So we can substitute this value here to get NB divided by NB plus 2NB, and this equal to N of B divided by 3NB, and now we can cancel out NB with NB, and this will be 1 over 3. So the probability is 1 over 3, the number of blue pins, or the probability of picking a blue pin. So the answer is B. The next question, you have an amusement park that has 2 jumping attractions called moon bounces in the shape of similar cubes. The larger moon bounce has a volume of, this is a cube, and the volume of that cube is equal to 4,800 cubic feet. The smaller moon bounce is half the length of the larger one. So the length of the smaller moon bounce is just half the length of the larger bounce. So what is the volume of the smaller moon bounce? Now we know that the volume of any cube of side L is equal to L cube, and therefore the volume of the small moon bounce, the small cube, is equal to L small to the power of 3. And then substituting Ls, which is this one, half, but we know that Ls is just 1/2 L, or the length of the side of the big cube. So continuing, we can separate the fraction from the other term. So we know that this is equal to 1/2 cube times this represents the volume of the big cube. And the volume of the big cube is given by 4,800. So that will be 1/8 times 4,800. And we can cancel 8 with 48, and that'll give you 6. So the answer is 600. So it's 600 feet cube. The last question. What is the area of a circle that has a circumference given by 12 pi? So we know that any circle of radius r, the circumference is defined as 2 pi times the radius r. So if the circumference is 12 pi, this is equal to 2 pi times r. So what you can do is you can just divide by 2 pi both sides, and these cancel out, and this is equal to 6. So in this case, 6 equal to the radius. We need to find the area. So the area is simply equal to pi r square equal to the area. So that's pi times 6 square, which is 36 pi. And that's it.